Good morning. I am Mr. Anand A. Rogni College of Engineering and Technology, Department of Civil Engineering. I am Assistant Professor and subject CE 8602 Structural Analysis 2. Here discuss about the influence line for shear force and bending moment. Location of maximum shear force. In a simple beam with any kind of load, the maximum positive shear force occurs at the left hand support and maximum negative shear force occurs at right hand support. Next, maximum shear force diagram. Due to a given system of rolling loads, the maximum shear force for every section of the girder can be worked out by placing the loads in appropriate positions. When these are plotted for all the sections of the girder, the diagram that we obtained is the maximum shear force diagram. This diagram yields the design shear for each cross sections. Next, bending moment diagrams. Bending moment diagram represents variation of bending moments. Bending moments diagram are drawn for only bending moments. If span longer than UDL for a maximum bending moment, the load on left side is equal to the load on right side in case of bending moment diagram. This is the maximum shear force diagram and maximum bending moment diagrams definitions. And next you can see the several point loads. The maximum bending moment for a series of moving loads is obtained when the average load on the left of the section is equal to the average load on the right of the section. The above statement exists in a system of moving point loads. In such case, each load is passed over the section and average load on the each side is calculated. The load when the crosses the section makes their heavier sides lighter and lighter side heavier and gives the maximum bending moment at the sections. And here there is example problem. A train of 5 wheels loaded crosses as a simply supported beam of span 22.5 meter using the influence lines. Calculate the maximum positive and negative shear forces at mid-span and absolute maximum bending moment anywhere in the span. So here there is a simply supported beam. There is action of external loads W1 120, W2 160, W3 400, W4 260, W5 240. The total span length is 22.5 meter. And from each load W1 to W2, the distance is 2.5 meter. W2 W3 2.5 meter, W3 to W4 2.5 meter, W2 W5 2.5 meter. Solution. So first there is a maximum shear force. For finding shear increment, W is equal to 1180 kilonewton and center C is 2.5 SI WC by 1 minus WL. That is 1180 into 2.5 divided by 22.5 minus 120. We are getting shear force 11.1111, that is positive. And for another thing, negative value is minus 28.8. Next, ordinate under C. Right side is equal to L minus X by L is equal to 11.25 divided by 22.5, that is 0.5. And left side X divided by L 11.25 divided by 22.5 is equal to 0.5. Ordinate under 400 kilonewton is equal to 0.5 divided by 11.25 into 8.75 is equal to 0.38. Maximum positive shear force is equal to minus 120 into 0.38 plus 400 into 0.38 plus 260 into 0.27 plus 240 into 0.16 plus 160 into 0.5 is equal to 295 kilonewton. So this is the diagram for the simply supported beam, and for each load you want to apply the influence line diagram. The neutral line top of it will be positive and bottom lines are in negative. This is the influence line diagram for shear force. And next, negative shear force. So already we finished the positive shear force and this one is the negative shear force. Find the shear increment. SI is equal to WC by L minus WL. is equal to 1180 into 2.5 divided by 22.5 minus 240 is equal to minus 108.89. So 120, so 160, 400, 260, 240. So at the interval of 2.5 meter, 2.5 meter, 2.5 meter, 2.5 meter. This distance from A 11.25 meter and remaining 11.25 meter. The next maximum negative shear force is equal to 240 into minus 0.5 plus 260 into minus 0.39 plus 400 into minus 0.27 plus 160 into 0.167 plus 120 into 0.056 is equal to minus 366.04 kilonewton. It is negative. So this is the simply put beam for the influence line for shear force for negative shear force. So the top value is positive and the bottom values are negatives. This is the maximum negative shear force. Taking moment about 120 kilonewton is equal to 160 into 2.5 plus 400 into 5 into plus 260 into 7.5 plus 240 into 10 is equal to R into X. X bar is equal to 5.72 meter. And maximum ordinate of our influence line is equal to 5.62. Ordinate under 160 kilonewton is equal to 3.20. Absolute maximum bending moment is equal to 120 into 3.04 plus 160 into 4.33 plus 400 into 5.62 plus 260 into 4.41 plus 240 into 3.2 is equal to 5220.2 kilonewton meter. This is the influence line for absolute maximum bending moment. Thank you.